10.6, officially day 2. Find the following term of the expanded binomial. The fourth term of x minus 7y to the 9th power. They're Asian beetles, they're an invasive species, that's why they're everywhere. So yes, I told you. Okay, now, if I want the fourth term of this expanded binomial, could I do the full Pascal's triangle expansion? Would it be a lot of extra information I'm finding? So, what if I only need a specific term? Is there a way to do it without expanding the entire thing? Yes, there is. You just kind of have to know your patterns of how the expansions work. So, first off, every term of an expanded binomial has 3 components. Something from Pascal's triangle, something from the first piece of the binomial, and something from the second piece of the binomial. Where am I looking at Pascal's triangle? Look at the exponent, 9th row of Pascal's triangle, and if I want the fourth term, how far am I counting in? Here's where you gotta be careful. It did not ask for you to do a combination, to do 9 combinations of a number. That's when we look one further. If I want the fourth term, when I'm expanding a binomial, yes, this is 9 combinations of 0, but it still ends up on the first term of the binomial. It's still the first number that goes into the expansion. So, how far in do I look? 4. Because this will be the first term, this will be the second term, this will be the third term, this will be the fourth term. Yes, it is 9 combinations of 3. I don't care. So, I'm looking at the fourth term of the 9th row. Do I have to write that out every single time? Absolutely not. This is for our notes. 84. Now, as for the x will typically be to some power. On the very, very first term of an expanded binomial, what power does it start to? The first part starts to the power of 9. On the second term, it would be to what power? I'm still talking about the x. So in this expanded binomial, we'd have x, we'd have this. Those of you who said 0 are talking about this, would have been to the power of 0. But I was moving on to the next term of the actual expansion. So I was talking about, like, after we get these three, we're moving on to these three. This one starts off to the power of 9 on the first term. On the second term, it's to what power? 8. On the third term, it's what power? On the fourth term, it's what power? 6. This is going to all of a sudden be, because it goes 9, 8, 7, 6. What's this one going to be to the power of? First term, it's to the power of 0. Second term, it's to the power of 1. Third term, it's to the power of. Fourth term, it's to the power of 3. Now, we could count these in every single time, but that would be a pain in the butt. Here's how I look at it. I start with the second term. This is always going to be one smaller than the term wanted. We wanted the fourth term. 1 smaller than 4 is 3. I start with that one because that's the one that counts up. 0, 1, 2, 3. So because it starts at 0, I need to subtract 1 because we typically start counting at 1. Here's the other thing to look at. If I have expanded binomial, before I simplify anything, I want you to keep a close eye on the exponents. This one, from what we did on Friday, was to the 6th power. In the first term, the powers were 6 and 0. On the second term, they were 5 and 1. On the third term, they were 4 and 2. 3 and 3, 2 and 4, 1 and 5, 0 and 6. What do you notice about all those pairs? They added up to 6. Okay, this one was to the power of 3. The powers before simplifying were to 3 and 0. 2 and 1, 1 and 2, 0 and 3. On an individual term, what will the powers always add up to? The power on the binomial. So it'll always simply be whatever added to this number adds up to that number. Now, those are the 3 things that go actually into the problem. Now I need to actually get the term itself. In other words, I need to simplify these things getting multiplied together. My calculator does the hard work. 84 times, in parentheses, this doesn't have a number, so I don't worry about it. This has negative 7 to the power of 3. Negative 28,812. It had an x to the 6th and a y to the 3rd. That is the 4th term of this expansion. What? I don't know what you're talking about. No, I have no good reason as to why I wrote C. Where am I looking at the triangle? 7th row, how far into it? How far in? 5 in. 0, 1, 2, 3, 4. Nope. Do I count at 0? No, don't mind me. 1, 2, 3, 4, 5. I have a headache. It's not going well. I got 35. I don't generally write it out as 3 separate things. I was just kind of showing you where things come from. I automatically go to this. 2x is going to be to some power. 3 is going to be to some power. Easier one to work with first is what the 3 is to the power of. 3 is going to be to the power of 4. Because it's 1 smaller than the 5th. Do I have to write this out every time? No. Which means the 2x is to what power? Why 3? Because the 2 powers have to add up to the exponent. Okay, I simplify. What am I typing into my calculator? Because I can't do the entire thing. What can the calculator simplify for me? Not quite. I also need what other number? 2 to the power of 3. Why did you all of a sudden put all of that in the exponent? I did not ask you to do that, calculator. Make sure you're getting all of the numbers. 22,680. What am I not allowed to forget? The x to the power of 3. Final example. I'm getting looks like y'all are angry at me because I threw up like a curveball in there or something. What's the curveball? We don't have the 13th row of Pascal's triangle. Could we continue Pascal's triangle and figure it out eventually? Does that sound like a lot more work than what we're willing to put in? Yes. Here is where going back to knowing things about how the triangle was originally built can help you. The 13th row, all of the rows are built off of combinations. The 13th row tells me which part of the combinations, the N or the R. The N. What's the R? If you're going to use the combination rules, I need the third number in, but remember that as you count in, if you're doing the combinations, it's combination 0, combination 1, combination 2. So if I want to go 3 in, I'm going to do 13 combinations of 2. That is going to get multiplied by 3x to what power? Or better yet, maybe I'll start at the -7. Make sure you bring a negative. -7 is going to be to which power? 2. In fact, if you do the combinations definition, these two numbers should always match. And the 3x should be to the power of 11. I put it into my calculator all in one go. Combinations of 2, not 12, times 3 to the power of 11 times negative 7 to the power of 2. That's a very big number. X to the power of 11. You can expect the exponents are going to get bigger and bigger as this gets bigger. Not to mention as these get bigger, the coefficients will get a lot bigger too. Okay. You won't have to do this version of it a lot, but it might pop up.